This is the another scheme that is for double beam spectrophotometer. Here again you can see at the left a light source, hydrogen lamp or tungsten lamp. Then there is another setup that is known as monochromator. Monochromator is a setup of two slips. In between there is a prism or grating. First the light passes through left slit, that will strike on prism. It will split the light into 7 colors, which then pass through the exit slit. After this, the light is splitted into 2 equal intensity by a beam splitter. These light, that is intensity of the light emitting from beam splitter are of equal intensity. Here you can see that both beam are denoted by I0 and I0. It means intensity of both the beam from beam splitter has equal intensity. One beam is passes through the reference cell and other beam is passes through the sample cell. As the reference cell contain only blank solvent, so no light absorbed by this reference cell. So here you can see that the light of I0 intensity is striking on reference cell, and emitting light also has intensity, that is I0. It shows that there occur no absorbance, whereas the beam that strike on sample cell, here left you can see that the intensity of striking light is I0, and the light that is passed through the sample cell has intensity of I. It has different intensity than striking intensity. Definitely the emitting intensity will have a decreased intensity. After the passage of light from reference and sample, it will allow to fall on a detector which compare both the intensity from reference cell as well as sample cell and compare it and generate a electrical signal which is now recorded on a graph paper in a recorder. This is the overall working of double beam spectrophotometer. Here double beam spectrometer, there is a difference from single beam spectrometer is that the light that is coming through this prism is splitted into 2 equal half by a beam splitter, and then they are allowed to fall simultaneously on reference cell and on sample cell. Now we are have a look on the procedure for the caffeine measurement. For experimental, we have to first of all prepare a stock solution of caffeine. We are going to prepare 250 ml caffeine of concentration 200 ppm. Now this stock solution is used to prepare different dilution of caffeine. We are going to prepare 50 ml of each dilution. To make a calculation plot, now we are going to prepare dilution of caffeine standard, that is 25 ppm, 50 ppm, 75 ppm and 100 ppm. Now take 1 ml of one of the dilution First of all, we are going to take 25 ml dilution. Okay. So take 1 ml of this dilution in a separating funnel and add 5 ml of methylene chloride into it, the mixture for 3 to 5 minutes. Hold the separating funnel for some time so that both the layer, that is aqueous layer and methylene chloride layer, get separated. When separation is complete, then separate the methylene chloride layer into a conical flask. As the density of methylene chloride is higher than water, so methylene chloride will remain in lower layer and aqueous layer on upper layer. When you have extract the organic layer, after extracting the organic layer, again add 5 ml methylene chloride into aqueous layer and repeat the procedure, that is checking for 5 minutes and allow to separate the both layer and extract the organic layer into methylene into conical flask. Both the portion of methylene chloride are collected in a single iodine flask. Now we have complete the extraction for 25 ppm diluent. Now we are going to repeat the procedure. We adopted for 25 ml of 25 ppm dilution for another dilution, that is 50 ppm, 75 ppm, 100 ppm, and caffeine soft drink sample also. So we are now going to repeat the entire extraction step for all other dilution and soft drink sample. After the completion of extraction for all dilution and soft drink, we have to ensure that volume of all the extract should be same. As the dichloromethane is highly volatile, then there is a chances that some of the methylene chloride evaporate and therefore equal volume are not obtained. So you have to select, you have to use a measuring cylinder and make up the volume of all the extract to same equal volume. That is, you have to ensure the equal volume of all the extract that you have received after extraction step. After that you have to determine the absorption of all dilution. That after the extraction step, you have to determine the absorption of all the extract you have obtained after the extraction step from each dilution and soft drink at 260 nanometer, taking methylene chloride as a blank. So now we are going to in our lab to perform the extraction, and thereafter we will go in our instrument lab to determine the absorption of each extractant and soft drink on UV spectrophotometer. This is the observation table. These observation we have taken from our instrument. We have take 4 concentration of standard 25 ppm, 50 ppm, 75 ppm and 100 ppm. For 25 ppm we have received absorbance 80, for 50 ppm 0.060 for 75 ppm, 0.144 for 100 ppm. We get absorbance, that is 0.214. For unknown soft drink, we get the absorbance equal to 0.179. Next, we have plot the absorbance, again concentration. On x-axis we have taken the concentration, and on y-axis we have taken absorbance. As you can see that we get almost linear line in concentration range between 25 ppm to 100 ppm. It means in this concentration range, Beer-Lambert's law hold good for caffeine. Next, in next plot we have determined the concentration of caffeine in soda sample. For that, we have taken the absorbance 0.179 from y-axis, and from which we have determined the concentration of caffeine in our unknown soda sample. We find that for our soda sample, the caffeine concentration in this sample is 19 ppm. For calculation, first we have to plot a graph between concentration of caffeine standard and absorbance. Thereafter we plot this concentration, this absorbance against concentration. It will provide a calibration graph. From this calibration graph, we determine the concentration of caffeine in soda by absorbance of caffeine sample, soda sample. From the graph we have found the concentration of caffeine to be 90 ppm. Precautions you have to take during the experiment, that similar step and similar environment you have to provide each dilution and soda sample as well. You have to repeat the extraction 3 times for each dilution and soda sample, and maintain equal volume at the end of extraction. That is, we have performed the extraction 2 times, and then we are diluting it to 50 ml. So you have to ensure 15 ml of extractant for each dilution and soda sample as well. Second caution you have to take that is that dichloromethane is highly volatile. Therefore, you have to release the pressure from separating funnel, so that any accident would not happen with separating funnel, as shaking will produce positive pressure in separating funnel. So you have to release pressure from separating funnel by removing separating flask. That's all. Today we have determined caffeine concentration in soft drink on UV spectrophotometer. Thank you.